So, hi everyone. Welcome to Geeks for Geeks practice. Yeah, can you just confirm that am I audible or not? So, hi everyone. Okay. So, yeah, I guess there's a comment from Silver Coders. Yeah, yeah, okay. So, yeah, thank you so much. Like, we will be coming up with such questions like in every week. Let's proceed. Let's proceed with today's question. So, let me share my screen. So, today's question, okay, before sharing my screen, I would just like to add few things, okay, what we are going to learn today. Today's question will not comprise of like very interesting or something very different or brilliant logic. Okay, today's question will mostly teach you how to use efficient data structures such that you can make your explanation easy. Easy in the sense for solving a particular problem, let's say A, I can solve it in 5 ways. Okay. But if you are good with data structures of a particular language, then you can solve it very easily. Okay. That is the concern for today's lesson. So let's start. Today we have picked a question from recently asked in Microsoft interview of printing anagrams together. Let's have a look at it. Yeah. So this is our portal in practice Geeks for Geeks. Okay. So here is the question. Now I'll explain you the question properly on the whiteboard. Okay, so let's go to the whiteboard. So if you carefully observe over here, the question says print anagrams together. Now, first of all, we need to understand what are anagrams. Okay, so anagrams is a word or phrase formed by rearranging the letters. Okay, of a different word or phrase, typically using original letters exactly once. So, for example, if you take act, okay, and if you take cat, these are anagrams. Why? Because letters used in them are same, but the orders are different. Okay, so this question is asking us to print all the anagrams together. Okay, like over here, if you carefully observe our output, arc and car is together because they are anagrams. Act, cat, and tack are again together, right? So we need to print it in that manner. Now, see, we have read the question, we have understood to some extent, but usually what mistake we do, we start writing the code just after this by understanding the question like, okay, fine, 70-80% I know the question, let's code. But there are few important details that we miss out, and I'll show it to you over here. See, what is it saying? Given an array of strings, we need to return all groups of strings that are anagrams. Fine, we already understood that. But this is the important line which I was talking about. The groups must be created in order of their appearance in the original array. This you need to understand because even if you form groups, let's say this group would have been written like car and after that arc, right? This is wrong because in your original array, arc comes before car. Okay, so these things you need to understand just by giving the logic for the question, making a group. Like you did a lot of hard work. Okay, you came up with the logic. You even wrote the code, but your output will not match with the output file of the portal, and things will go wrong, right? So these are the small things which you need to understand. Okay, so this is the sample case. Okay, which we will look for explanation or clarification. That's what we already saw just now, right? Like if you look at the second group, see, act is coming first, hence it is first in our group. After that we have cat, and after that we have tack, right? Okay, and what is our task? There will be a function anagrams given. Okay, we need to complete this function, and it takes a list of strings as input. We'll see. Okay, we'll see when we'll code like how is it taking list of strings. Okay, at that time I will put much focus onto that. Okay, so it is taking list of strings as input and returns a list of groups such that each group consists of all the strings that are anagrams. I'll try to brief it right now, but if it is not clear, it will become clear when I'll proceed with the code. Okay. So it is saying that there is a function anagrams which is taking a list of strings. Now this is that list. Okay. This words over here is a list of string. and it returns a list of groups. So this is your list of group in which your first element is again a list. Okay, so there is a list inside a list. So it is a list of groups such that each group consists of all the strings that are anagrams. So if you carefully observe, our first group consists of anagrams to each other. Next group consists of again anagrams. Okay, so it is like that. And the explanation says there are two groups of anagrams. Arc, car make group one. Act, cat, and tack make group two. Okay, so I hope the logic is, or sorry, I hope the question is clear to you. So like if you have any doubt in the question, you can ask in the comment section right now. All right. If it's clear, then let's move to the logic. Okay. Let me clear the screen over here. Okay. Let me take the same sample input in a fresh screen to understand or rather to develop the logic for this question. See, this kind of questions could become very tricky at times, or like you might not be able to understand it properly, like how to implement. Like if you carefully observe over here, just a second. Yeah, like you carefully observe over here, we have act, cat, and tack as anagrams, right? And arc and car as the other group. What solution comes to my mind is like, okay, I'll try to store sometimes, or rather, I'll go with one solution. Like I'll go through each of the words. Okay, I'll go through each of the words and I'll see like which words has similar letters. Okay, which words has similar letters in the sense, see, act, cat, and tack has same letters, right? They are rearranged somewhere, but they have same letters, right? So one thing that comes to my mind is, can I sort? Like, will sorting help me? Okay, uh, just a second. Why is this blinking like this? Or we can do one thing. We can go to the same page. Okay, and let's zoom it out. Yeah, we can remove this. Give me a moment. Let me clear this. Yeah, and let me take this side. Yeah, and let me just zoom in. All right, great. So one thing that comes to my mind is, if I see these words act, cat, and tack, I see that they have same letters rearranged in different manner. So what if I sort each of them? Sort each of them in the sense, this act will become act. Okay, this arc will become ACR. This cat will again become act. Right. This car will again become ACR, and then tack will also become act. So the words at the zeroth position, like if I do the indexing, yeah, the words at the zeroth position, second position, and the last one. Okay, let me do the indexing first. 0, 1, 2, 3, and 4. So words at the zeroth position, second position, and fourth position are same, like after sorting. So I am sure that 0, 2, and 4, these three indices, okay, 0, 2, and 4, these three indices can be those words which are forming an anagram, right? And if you look carefully at the words at index 1 and index 3, then this again will become those words that can form a separate group, right? So there is one approach, like I can either make a copy of this words uh, array, I can sort it, and after sorting I check, okay, which positions have the same words present, like all of them are becoming act if you carefully observe over here, and which positions have different words. Okay, and accordingly what you will do, let's say I'll store the indices over here. I'll store 0, 2, and 4, and I'll store 1 and 3, right? These are the two groups I know. So I'll go to my original array. Okay, I'll go to my original array and I'll pick those words, put them in a list, and finally return it, right? Similarly, I can do that for 1 and 3. So the logic is pretty simple. Like we are going to sort our given word array. I'm going to copy it, okay, in a separate and sort. I cannot sort the original one, otherwise I will lose the track of the word, right? If I sort the original array, because it will, all of these will become act and ACR, right? So it will become act ACR and act if you carefully observe. So that is the reason I'm saying that I'll make a copy. So I hope the logic is clear to you. We'll do the same thing, but with a, yeah, we'll do the same thing, but with a better approach. Better approach in the sense, better data structure, I mean to say, okay? So we are going to use over here map, okay? We are going to use over here map. Now you will understand the importance or the power of data structure, okay? Like when you are good with logics, but still you find difficult to implement, then you need to rely on data structures. So you will see over here how map will become handy, okay? So map will take two things, okay, key and a value. My key will be a string, which will be basically the strings present over here. Okay, we'll see, but let's first generalize. Key will be a string and our value will be a vector in C++ or a list in Java, okay? Vector of strings. Now, how this will work, I'll just explain. What I'll do, I will run a for loop on this particular given words array, okay? I'll run a for loop. I will, or any loop which you want. I'm just talking about traversing the array. And I'll pick the first word, sort it. I will sort it separately. I'll sort it. I'll not after sorting. I'll not again store it over here. Okay. I'll pick that word and I'll sort it separately. I'll sort, and after sorting, I'll check in my map. Is this particular key present? Like if I sort this one, this ACT again becomes ACT, right? So I check. I check over here. Is this key present? If it's not present, we are going to insert. Now comes the interesting part. What are you going to do over here? So over here, things will work somewhat like if it is ACT, you are storing it as ACT as key. And for vector of strings, you are going to store your original strings. Okay, so you are going to store ACT over here. Now it might sound confusing right now because if after or before sorting, ACT always remains ACT. But give me a moment, I'll clear that out. So let's say we come up with ARC. Okay, let's come up with ARC. Now this after sorting becomes ACR, right? So again, you're going to do the same thing. You're going to search in your map. Is this key present? If it's present, then you're straight away going to insert the original string ARC in that particular value. Okay. If it's not present, you're going to do ACR, and inside your vector, you will have ARC, right? So till now, what we have, one key has ACT and its value has ACT again, and the next key has ACR, its value has first value, like it's a vector of strings, so in the vector first string is ARC. Let's proceed forward. So we have cat. Now we sort it, it becomes ACT, right? We check in the map, is ACT present? So yes, it is present. What we do, we insert the original string, so we insert cat over here, right? Now let me just complete the dry run. After that, I'll show you a few points that we have got help from this data structure, right? So after this, we encounter car. Car again after sorting becomes ACR. We check, okay, ACR as key is present. Let me insert car. After that, we go to tag. After sorting tag, it becomes ACT, right? ACT. We find that, okay, fine, ACT as key is present. So I'll insert tag over here, right? So if you carefully observe, I have my map ready with two keys, ACT and ACR, and this is my corresponding value. Now, initially at the beginning of this today's lecture, I told that we need to also ensure that the order is maintained. Order in the sense, if this is your original input array, okay, see ACT, after that CAT should come, and after that tag should come. So that is maintained. See, it is automatically maintained. ARC, after that CR is come, see, that is maintained. It is automatically maintained. So this is the beauty of data structures, like how well you are acquainted with data structures. See, someone who would have not known map, okay, what he or she would have done, he or she would have created another copy of this words, okay, let's say words one, yeah, and would have sorted and would have found out that okay, the index 0, 2, and 4 is there, which I need to take in one group. Okay, and after that, index 1 and 3 is there, which he or she needs to take in another group. See, it's, I'm not saying it's a bad solution, but it's like you are not good with data structures. The interviewer will straight away understand that he or she is not well acquainted with data structures, right? So I hope the logic is making sense to you. Okay, and as well as the data structure. Yeah. So as I said in the beginning only, like today's lesson will be more of appreciating the power of data structures. Okay, so let's go to the code and have a look at it. Okay, if required, like if you have any doubts, I'll again come to the whiteboard. Okay, yeah, so let me just maximize this. Yeah, just a second. Yeah, yeah, so this is our code. See, we have a function anagrams. Now you need to understand very carefully that what we are returning. We are returning a vector inside which the element is again a vector of string. Okay, so if you carefully remember, let's say this is your vector, okay, and inside this you again have again vector of strings. Let's say it's containing a1, a2. Okay, these are strings by the way. In the logic, anyways, we have seen those words. Like if we go back to the whiteboard, but it's a like vector inside a vector, right? So if you have any doubts, you can like ask me right now. No issue in that. So let's proceed forward. And what you're getting as input, a vector of string. So it was something like, in our case, if you remember, it was ACT or something. Or let's go back and check it out. Okay, what was that? Yeah, so it was. If I go to the whiteboard, it was ACT, ARC, CAT, car, and tag, right? So this is the vector of strings that is coming as input to us. And what we are returning? We are returning at the end vector of vectors, right? So inside this, we will have two vectors. Okay, the first one will contain your R, comma, car, and the next one will contain your act, comma, cat, comma, tag, right? So I hope this is clear to you. Now, let's get back. Let's get back to the screen. Yeah, let me maximize it. Okay, fine. So we are taking a result which is again a vector of vector, obviously, because that's what we are going to return at the end. And as I said, we are using a map which takes string as key and vector string as value. We saw, right? We saw while we were going through the logic. So there is only one for loop, okay, and that's it. Sorry, two for loops. Let's focus on the first one first. Okay, like this one. Let's see. So it is going from I equals to 0 till your string list dot size, basically till your full vector length dot size, right? And it is doing I plus plus. In the very first time I pick my first string from the vector, okay, I sort it. I sort it. So if you remember, like if I go back to the whiteboard again, just a second, I was basically sorting this, right? ACT, I was sorting. ARC, I was sorting, right? Every one of them I was sorting. So what I'll do right now, let me just uh, okay, ACT, ARC, CAT. Fine, let me go to the whiteboard now because every time toggling is becoming big hectic. So if you need any help, like you can go back and relate it with the sample input, right? So we are sorting each one of them, and at one time, if we get let's say, or let's do one thing. Let's write the sample input over here and let's try to dry run this code. Okay. I think that will make much more sense. So let's do that. Let's do that. So yeah, so let me copy the sample input from here. Okay. Fine. Yeah, let me paste it over here as a comment. Maximize it. Yeah, fine. So there you go. Now I have it. So we have ACT, we have ARC, CAT, CAR, and TAC, right? Okay. So the very first time I have an empty unordered map, okay, which I have named as UMap. I come inside, I take this ACT, I sort it. After sorting also it is still ACT, and I check. This is how you do it in C++. UMap, if it is there, it will push back into the corresponding value. Okay, like if you observe the value over is vector string, so it will push back. If it is not there, it will create new one for you. So UMap ACT, you are pushing back inside that your exact string list I. So we are pushing back right now ACT, right? So what you have prepared till now in your map, ACT comma ACT. Okay. In the second iteration, what you're doing, you take this ARC. So at that time, what you do, you prepare ACR comma ARC, right? Because you will sort and this will become ACR, you will push this. In the third iteration, you again sort this, it becomes ACT, it is already present. So you are pushing over here, you're pushing this cat, right? After that, you come up with car and you push it over here because if you sort car, it will become ACR, right? If you sort car, it will become ACR. And after that, you're pushing it over, right? Because you already have ACR as key present. So if I am going too fast, you can let me know, okay? Or you can go back to the video and watch it again. Like because I've explained the same thing in the logic as well, right? Now, if you take tag, this again becomes after sorting ACT. So you are going to search in your map what is the ACT is present or not. If it is there, you are going to insert the exact string. Okay, this is what you need to observe. So what do I have in my map finally? I have two keys ACT and ACR. In the first key, the value is a vector of strings, which is ACT, CAT, and TAC. And in the second key, I have vector of strings again, which has the value ARC and CAR. So order is also maintained, and I was able to do it without copying my original vector into another vector or an array. Okay. So after this, now comes the part where you need to return the result. And how do you need to that do that? You need to return a vector of vectors, right? So if you carefully observe, you are going to take this vector and this vector, and this should be put in one more vector. Okay. So this as a whole will come over here. Okay, this as a whole, and this as a whole will come over here. So what you're doing, you're running a loop on your map because you know that you need to uh, run a loop on your map because your map only has those vector of strings, right, as values. So that's what we are pointing with itr arrow second. Okay, this itr is nothing but the iterator which is running on our map. Okay, and you're going from begin till end. Okay, and you're doing itr plus plus. So basically you're going through each key value pair, right? So basically you're going through each key value pair, and once you see that you have found your first key, this is your iterator which is pointing to this particular key value pair right now. You take it second, which is a vector of strings, and you push back in your result. Now carefully observe over here. When you are pushing back your itr arrow second into your result, that should be compatible. Compatible in the sense, see, this result is supposed to store a vector of string, right? So now I hope you are able to relate. Like, why have I taken vector of vector as result? Because in result, each element is again a vector, right? So I hope this is making sense to you. Let me clear the screen a bit. So we are pushing back itr arrow second every time in my result, and that will store all the vectors which are values in my unordered map as elements in my result. Okay, and that will be done, and we finally return our result, right? So what we are doing basically, we are sorting. So this will take time of n log n, where n is the length of the string. Okay, and you are running it on a for loop which is going till your entire vector size, right? And again, sorry, your entire entire input vector size. and at the end you are running it on your, like, you are running one more for loop on your map, right? So I hope like this is making sense to you, like the whole logic and the code. So as I told like earlier also, today's question, I know that logic was not very much extraordinary or anything, but with the help of data structure we were able to simplify it, right? Otherwise this could have gone to a big long code, okay, which would have made things very much difficult for us at times, because I have seen people doing mistakes, like they are not aware of the data structure, they have framed the logic properly, and they go on writing longer codes which are not required if you use good data structure. Okay, so let's compile this. Okay, so your output is coming properly. See, we are not bothered about how the output should look like. This is how you code in online portals. Like in this is our Geeks for Geeks practice portal. If you observe, it was only asked to fill this part of your code. You are not required to touch the driver code. So I am not supposed to see that okay, new line should be there after every group or not. I'm just bothered about how am I returning my result. Okay, that is a vector of vectors. Okay, so I wanted to make this thing clear to you. So let's submit it now. Yeah, so it has got executed properly. So yeah, this was it for today. And as in my every live lesson, I gave some input on the question. So today I would just like to say that in these kind of questions, read your question properly. Okay, read it properly. Try to identify what data structures you know and what can be worked out over here. Why I'm saying to read it properly? Because if you see over here, let's say if I would have not read this, if I go to the task, or it's over there only, this one, the groups must be created in order of their appearance in original array. This is a very important line which you need to understand, right? So read question properly. Although this is a medium level problem, maybe due to the use of good data structure. Okay, otherwise people can create a mess over here. So that's it. That's it. Like read it properly. Make use of good data structures. Okay, try to do some more questions on maps or different data structures so that you will be able to categorize your questions. Right. If a question is given to you, you should be quick enough to categorize. Okay, which data structure I can use in this question. That's how you will be able to practice. Okay, so for that you can practice over here. Okay, this is our portal at Geeks for Geeks. Uh, Fine. So if you have any questions, let me know. All right, then this is it for today. We'll come up with more good questions asked by product-based companies in their interviews, okay, as we proceed further. Thank you so much for joining Geeks for Geeks practice. Meet you in the next live lesson. Yeah, so there's a question, how can we start with data structure, learning, and practice? See, for that, what you need to do is you need to first assess like what you already know, in the sense, if it is, if you're trying to start from zero, okay, if you're trying to start from zero, you can go to our practice portal. Okay, there are categories of questions, like let's say you can pick arrays first, right? Like it's always to pick from the basics, so you can start with arrays, then you can gradually increase your level, like you can do some questions on stack, then queues, okay, then maps. Means I'm just saying that you can go gradually if your level is like, if you totally want to start from beginning. But let's say if you are intermediate, okay, you know data structures, then I will suggest you to pick 10-20 good questions. See, pick 10-20 good questions which are like, which will give you better clarity and variations. I'm not saying like do similar kind of questions every time. Like if you pick, let's say, arrays, try to do some questions on finding, let's say, maximum minimum, okay, some questions which implement algorithms like Cadence algorithm. We also have one video for that on our channel, okay. So these are some good questions on arrays, okay. Now let's say if you go to stack, try to do some questions on next greater element when you move from the right of the array, okay, next smaller element when you move from the right of the array. There's a very very famous question of calculating area in histogram, okay. Similarly, if you go to queue, try to do some good questions on queues, okay. Like this is how you can start with data structures learning and practice. You will yourself realize at one point of time that I am confident in this particular data structure. Now I can go to the next one. So try to do 10-20 questions from each one of them, okay. Try to assess your level. See, nobody knows you better than you, right? If you have any problem, you can always comment over here and you can ask doubts, okay. That is not an issue, but this is how everyone begins, okay. Try to assess where you are right now and then proceed. So I hope I was able to answer your question.